Hello, thank you for joining us. This is Brent Phillips from IntelliMagic. IntelliMagic is the leader in storage performance management solutions for zOS platforms, with our software in use around the globe today by some of the world's largest storage vendors and mainframe end-user sites. This brief presentation discusses how changes in the zOS storage architecture have affected visibility into the performance of your workloads on your storage hardware. The important takeaways are where I/O queuing happens, that there's been a shift, that there's a visibility gap that's been created by the way the architecture has evolved, and that there's consequences for that gap that are important for the IT operations. We'll also discuss briefly how to mitigate those risks and the overall impact on IT operations. In the early days, DASD was connected typically to a single host only. Consequently, it was easier to manage and easier to see what was going on with the I/O. You could use host-centric reporting to identify any I/O queuing. These days, storage is much more complex, and that complexity has also introduced some difficulties in understanding I/O and I/O constraints. The storage boxes are much more powerful than they used to be, so they are connected to multiple LPARs, not a single LPAR, through switches and directors. This diagram on the right represents a modern disk subsystem with the FICON host adapters on the front end of the box, the cache, the processors, and the bus in the middle. And then on the back end of the storage system, you have the device adapters that control the actual physical devices, which are the spinning disks and any solid-state disk configured in the box. It's important to see how the queuing of I/O requests has shifted from the host to the components inside of the storage system due to features like FICON versus SCON, for example. FICON is a multiplexing technology that handles multiple transmissions at a time compared to SCON, which handled only one transmission at a time. PAV and multiple allegiance are also features that have essentially opened up the pipe so that I/Os are no longer waiting on the host side, but they get sent down to the storage system because it's much more capable and it's typically able to handle it. But there's always a bottleneck in the environment. These days, in today's architecture, that bottleneck is the components inside of the box where the queuing happens, and that's where the visibility gap exists. Most I/O performance reporting is still host-centric, despite many years having been invested in things like SAS and MXG. The performance tools and reports in place are reporting really just on the symptoms of response time and its subcomponents, but not on the root causes of those service times, which are the overutilization of the specific components inside of the storage system. What you really want to do is understand the capabilities of the components, the host adapters, the cache, the back end, and physical devices, and how your workloads are driving those components. To be able to tell when you are approaching that critical level of utilization where they are going to start to introduce delays in response times. One of the consequences of this visibility gap inside the storage system is a higher risk of storage service level problems because you cannot see what's going on with your hardware components that are driving the performance. So if you're like most sites, you find out about performance issues associated with storage after response times are already causing end user issues, instead of having the instrumentation to see what the hardware components involved are doing and how they're nearing critical levels of utilization where they will start to introduce delays if your workloads spike up just a small amount. So that's a reactive process of finding out about storage performance problems as opposed to a proactive process of monitoring the health of the hardware in an easy and automated fashion. It's also important to note that with today's architectures, negative surprises with I/O can occur much more quickly than they used to. The response time, or the knee of the curve of the response time, is much sharper than it used to be. With older architectures, you could pretty much tell where you were in the life cycle of the hardware just by monitoring response times, because it would grow in a linear fashion as the box became more busy. These days, the architectures are much more powerful, and they are able to keep those response times low until any particular component inside the storage system reaches that critical level of utilization where it will start to introduce delays, and then the response times spike up much more quickly. For example, the host adapters on the front end of the storage system are one of the two most common bottlenecks in today's architectures. The other common bottleneck is the physical devices on the back end of the box when they cannot keep up with the request to stage the data from the devices into cache or to destage it from cache back to the devices for the writes. Hotspots are defined as the device not being able to keep up with all those back-end IOs between the cache and the devices. So that's happening more and more with the larger capacity disks that are not spinning any faster than they were 5 years ago, but they're holding 4 times or 8 times as much data as they used to. And that's why your high access density workloads will need to be placed on solid state devices to avoid more and more problems in this area. There are also storage efficiency consequences of the visibility gap, and these are driving up storage hardware costs unnecessarily. It's not at all uncommon that the storage hardware is producing delays during peak periods and people are thinking it needs to be upgraded, the hardware, when in reality it can often handle twice the workload at the best of breed service times with just a simple rebalancing of the workloads. This is actually quite easy to keep in line with the IntelliMagic Balance tool, and it can dramatically increase the useful life of the storage hardware and increase the margin of safety to handle spikes in workload. It's important to note that the performance capabilities of the storage hardware are actually driving costs much more now than the space requirements drive the cost. If that were not true, everyone would be configuring their storage system with the largest drives, the 2 terabyte SATA drives, for example. But of course that will not work with the zOS workloads today. Despite performance being so important, most sites still have no easy visibility into how well balanced their workloads are across the components inside of your storage hardware. The result is that it's very common to have some resources being hot during peak periods while other resources are virtually unutilized, and that limits the total throughput that the configuration can safely handle. Another important consequence of this visibility gap is in the area of the CPU and overcompensating with the CPU. For most online and batch jobs, DASD is a very significant component of the overall time. There are often opportunities for quick wins in overall performance times by addressing the I/O side of the equation. We've had customers document the avoidance of an additional CPU engine to get a desired performance win during the batch hours, for example, by addressing the storage performance of the hardware. If you can, for example, cut in half the average I/O response time for a job by seeing and addressing unnecessary delays in the storage hardware, it's going to be far cheaper than buying more CPU power to cut the same amount of time off the CPU wait times. With the right visibility into the I/O infrastructure, these opportunities for optimization can be easily identified and addressed. An effective storage performance management solution will bridge this visibility gap and enable you to see inside the storage system and correlate your specific workload metrics with the capabilities of the specific hardware that your workloads are running on. This is the only way to get early warning and quick root cause analysis, and it's the only way to maximize your storage hardware dollars. IntelliMagic is not aware of any other solution on the market that gives you detailed visibility into both the logical zOS view of your workloads and also into how those workloads are mapped onto the hardware storage components from any mainframe storage vendor, and how close to the edge of the capabilities of those components you are running during your peak periods. This is the visibility that's required to implement today's best practices, and it will demonstrably reduce SLA risks and improve cost efficiencies. Please see the published article about SPM best practices on our website for more details. The impact of having an effective storage performance management solution is that you'll be able to use the early warning capabilities in the solution to avoid outages or slowdowns, which can be very expensive to the business. This automated daily health check of how your hardware is handling your workloads will give you an easy and quick proactive process that also enables you to get the most out of the hardware resources that you've paid for. When there are performance issues, all the right metrics are at your fingertips in the database without having to call in the hardware vendor for specialized reporting. This allows you to see and resolve issues much quicker. And the knowledge about how the hardware is performing will also shift the balance of power between you and your vendor when you're deciding how to configure your storage hardware. IntelliMagic has many detailed white papers, articles, and webinars on our website for both storage performance management topics on mainframe environments as well as distributed system environments. I'd like to thank you for your time, and please contact us if we can answer any questions.